In this video, I'm going to show you examples of working with sets by using their built-in methods and different operations on them. And as you can see here, I have a variable called my_set, and its value is a set containing the elements 1, 2, and 3. Now, if I wanted to add an element to this set, I would use the add method. So under here, I'm going to type my_set.add. And if I mouse over this method, it tells us that it takes an element and it adds an element to a set. This has no effect if the element is already present. So if I tried to add a 3, which is already in this set, and run this, we'll see that we just get the set of 1, 2, and 3 back. It did not add a second 3 there. But if I try to add a 4, it will add the 4 to the set, and now my set has 1, 2, 3, and 4. Now what if I tried to add something like a list? So I'm going to pass in a set of square brackets here, and I'll give it the element 4. When I run this, it's going to give me a type error and tell me that it's an unhashable type list. What this means is sets cannot contain unhashable types. Any type that we pass into a set must be hashable. So numbers, integers, strings, tuples, frozen sets, as long as it's hashable, it can be put in a set, but if it's not, it cannot go into the set. Now, if I wanted to remove an element from the set, I would use the remove method. And if I mouse over this, we'll see that it takes an element and it removes an element from a set, and it must be a member. If the element is not a member, it raises a key error. What this means is that if I try to remove a 4, which is not a member of this set, when I run this, I get this key error, and it's letting me know that 4 is not a key that's in this set. But if I try to remove the 3, which is in the set, it will remove it, and my set will no longer contain that 3. Now, there may be a time where I don't know what values are in my set. So how can I remove or attempt to remove a value that won't crash the program if I forget to handle this error? Well, you could use the discard method. So the discard method works exactly like the remove method, except for it will not cause an error if you try to remove a member that's not in the set. So if I run this with this 4 here, I just get my set back as 1, 2, 3 with no errors or issues. And if I try to remove a 3, which is a member of the set, it removes it and I get my set back with only the elements 1 and 2. Now, if I wanted to clear every element from my set, I would use the clear method, which removes all elements and leaves me with an empty set. And when I run that, we get the set constructor down here indicating that this is an empty set now. And if I wanted to just get rid of the set entirely, wipe it out of memory, get it out of my program, I don't want any trace of it at all, I could use the del keyword to delete my set. And now when I run this, I'm going to get an error when I try to print my set out, because after this del keyword here, my set no longer exists. It's gone. It's no longer in memory. So this has no idea what the name my_set is referring to. Sets also have a pop method that returns an arbitrary element from the set and removes it from the set. Now, if I were to switch my numbers around here, so it's 3, 2, 1 instead of 1, 2, 3, and output this set again, we'll see that it comes out as 1, 2, 3. And this seems to be the case with integers. It always puts them in order from lowest to highest. So just to show that the pop method always returns an arbitrary value, I'm going to make this set be a string of characters. I'm going to do that by calling the set function and passing it the value world. And down here in the print function, I will call the .pop method on this my set here, since it's going to return one of these characters here, and then I'll do a comma and also print my set. So when I run this now, we'll see that the pop method removed R from the set, and that's what it returned, and then my set contains W, L, O, and D. Now if I run this again, we got the R again, but this time the set is in order O, D, W, L, and if I run it one more time, now the pop has returned the D, and these are in a different order again. And this is because sets are unordered. The last thing that I want to show you is the update method. So the update takes a set and adds a variable number of iterables to that set to create a union. I'm going to set my set back to being the numbers 1, 2, and 3. And I'm going to create a new set called my other set. And I'll give those the number 3, 4, and 5. And then under this, I am going to type myset.update. And if I mouse over this, it tells us it updates a set with the union of itself and others. So when I pass in my other set, it is going to create a union between my set and my other set, which is all the unique values between the two sets. So it's going to be 1, 2, 3, 4, and 5. And down here in the print function, I'm only going to print my set. And when I run that, we get the output down here, 1, 2, 3, 4, and 5.